Greetings to the one of all present here. This is Harsh Mishra standing before you all from Lakshmi Prasad Memorial Public School, and today I am here to explain you and demonstrate you about our one of our topic from our mathematics subject, that is matrix. What is matrix and how it evolved for a very far distance. If we talk about a brief history, the matrix was earlier used for solving linear equalities, but nowadays it is come far and exists in more of the uses. So first of all, our question will arise that what is matrix? So matrix is nothing but a order rectangular array of any numbers or function. So basically it is demonstrated by a square bracket and all the entries in it. All the entries in it are known as numbers, and these entries defines about order of the matrix, and order of the matrix can be defined through the numbers and the numbers in the rows and the columns. Here we have 2 rows and we have 3 columns. So basically the order of the matrix will be 2 cross 3. The first order defines about number of row, and second will define about number of column. So what are types of matrices and how they are used in our daily life? So matrices are basically of 7 types in whatever we have studied. The first is column matrix. What are column matrix? If a matrix contains only one column as carrying out its all entries, then it is called as column matrix. One of example are, here we are having only a column as its entry, and this is an example of column matrix. Similarly, there is row matrix which have only one row as containing its all the entries. And its example, so these are the two types of matrices, and many more are also there. The third one is our diagonal matrix. Before discussing about diagonal matrix, we first of all understand about what is square matrix. If we have a matrix of m cross n such that m is equal to n, that is number of rows are equal to the number of columns, then such type of matrix can be called as square matrix. And diagonal matrix is nothing but also a type of square matrix. It is such type of square matrix in which the elements other than its diagonals are 0. If we take about any example, Here we have a matrix of 3 cross 3 order, and we can see that all the elements except diagonal elements are 0. So this is basically an example of diagonal matrix. Moving ahead, we have a scalar matrix. If there is an square matrix such that its all diagonal elements are same, for example, here we can see that the elements at the diagonals are same. So basically what this happens, a diagonal matrix is also a square matrix is also nothing but a diagonal matrix, and it is not necessary that all the diagonal matrix are said to be scalar matrix, but it is needed that every scalar matrix must be a diagonal matrix. Such like scalar matrix, there is identity matrix. Identity matrix, it is nothing but a type of scalar matrix and diagonal matrix in which the diagonal entities are 1. For example, if there is n matrix of 2 cross 2 such that its diagonal elements are nothing but 1, then it is an example of identity matrix. Moving ahead, our last one, zero matrix. Zero matrix, it is nothing but if a matrix contains only 0 as its element, then it is called as zero matrix, or also known as null matrix. For example, if there is a matrix of 1 cross 1 such that it's having element 0, then it is called as zero matrix. Now we will talk about two ways. If we are also having another matrix of 2 cross 2 such that its all elements are 0, 0, 0, 0, then it is nothing but an example of zero matrix. Moving ahead, we have also two types of matrix. First one is symmetric matrix. If there is a matrix such that if we have any matrix A, if we have a matrix A such that if we do transpose of it, we get the matrix again, then it is a type of symmetric matrix. Before we proceed about what is the symmetric matrix, we first of all understand about what is transpose. So transpose of matrix is nothing but basically we are converting all the elements of row into columns. If we have a matrix of m cross n and we have transposed it, then it will become a matrix of n cross m, and all the elements of its row will come in its column, and all its column elements will come in its row. So basically here in the symmetric matrix, if we transpose any matrix of n cross n, and we get written a matrix of n cross n such that its all corresponding elements are same in both the matrices, then it is called as a symmetric matrix. And our second one is our skew symmetric matrix. Skew symmetric matrix if we are having a matrix A such that its transpose is equal to minus A, that means if any element of Aij representing our all possible value of I and j such that its transpose is equal to minus Aji, then it is nothing but a skew symmetric matrix. At last, thank you. So that all was from my side. Thank you for listening.